Today we're going to study algebraic expressions. We started it briefly last year, and we're going to be doing simple algebraic expressions, and this is something that we do all the way through math class, because it's modeling a word problem with math, so it's kind of something we do all the time. So our objectives today are I can evaluate simple algebraic expressions, so you're evaluating them, and your language objective is being able to write algebraic expressions from situations. So we've got a lot of vocabulary today, so I would like you to write these two, and then I've got a whole other slide here. So I would like you to write down a variable in algebra first, and I'm going to kind of talk while you write that. So a variable is a symbol that represents an unknown quantity. So it can be, usually it's a letter, lowercase letter, and it's some sort of unknown quantity. That means we can put whatever we want in there. And algebra is what we're studying today. It's the branch of math that involves expressions with variables. So anytime you have a letter with what you're working with, you're actually doing algebra. Then when we get to algebra class, we just do a lot of it, that's all. Okay, pause the video if you need to finish these two. Now, first I'd like you to write all these down and make sure you leave room for algebraic expression and coefficient and term, and so that I can give you examples. So pause the video, write this down, and then I'll go over the words. So substitute in algebra is replacing two equivalent quantities. So just like right now, you have a substitute for me. So it's just one person that replaces another person as a substitute. She's just as qualified and can help you with anything, and as I would be if I was there. So we're just like you're doing in the real world, substitution in math is replacing two equivalent quantities. They are the same thing, and you can use them interchangeably. An algebraic expression is an expression that contains variables, numbers, and operations. So we've got a whole super long one right here. That's an algebraic expression. As long as you've got variables, numbers, operations, you've got it. And a regular expression might just be numbers and operations. Algebraic's when you throw the letters in it. A coefficient. Now this is a word that I use a lot in the upcoming years. So it's the number that's multiplied by a variable. So for example, 3x. 3x. The 3 is a coefficient. Okay, and we probably talked about this when we did combining like terms. You combine the coefficients. A term is a piece of an algebraic expression separated by an adding or subtracting sign. So just like 3x is a term, comma, 8y is a term. This is x is a term. 3 is a term. 4d is a term. We talked about that, or I'm sorry, 4d squared. And we talked about that when we did combining like terms. So just kind of review that. And we're going to define a variable, and we're going to go over that on the next slide. You probably remember that from last year. So defining a variable down here at the bottom, it's where you choose, if you choose a variable to represent an unknown quantity, then you need to define it. So up in this problem here, A is defined as the age of the person. Okay? And they're going to tell us that in the example up there. So making sure if you choose a variable that you must define the variable. So now, substitution is that evaluating an algebraic expression. Here's an algebraic expression. I'm going to be asked to find an answer. In the problem it says, use the formula where A is the age of the person, there they define the variable, to find Jessie's minimum training heart rate if she is 15 years old. So we know that A is the age of the person, And we know that Jesse is 15. So these two things are equivalent. That means we can use substitution. So we're going to substitute 15 in place of A, and then we will have no variables, so we'll be able to evaluate our formula. So go ahead and first you're going to substitute. So 3 times the quantity 220, subtract 15, and then it's just all being divided by 5. So you should notice that I took A and replaced it with its equivalent quantity of 15. And now it's just an order of operations problem, so use your order of operations to simplify to find the answer. So I'm going to deal with my numerator since my denominator's done. I'm going to figure out my grouping symbols. So it's 3 times 220 minus 15 is 205, still divided by 5. And then 3 times 205 would be 615, still divided by 5. And now I need to know 615 divided by 5, which would be, if you don't know, just do your long division off to the side. It's no big deal. 5 goes into 6 one time, get 1 left over. Oops. Subtract back that. 1 left over here, drop the 1 down. 5 goes into 11 2 times. It's 10. And 5 goes into 15 3 times. So the answer is 123, and then it's a word problem, so you can write your sentence. So the minimum training heart rate for Jesse is 123. And now do you know what the label for 123 is? What's the label for heart rate? Beats per minute. Now, if you didn't put that, that'd be okay, because you told us it was heart rate. But since I knew it, I wanted to put it. Okay, so that's what we do when we need to substitute and evaluate an expression. Now, on this word problem, we're going to use a 4-square model. So what I want you to do is first, we have 2 things we're going to do. We're going to write an expression, and we're going to also answer a question. So make sure you pay attention that there's 2 things to do. First thing I'd like you to do is write down the word problem and the 4-square. So pause the video and copy that down. So I call this the 4-square model because there's 4 and then the question in the middle. So we have the know box, figuring out what I know, what strategy I'm going to use. I'm going to show my work in the corner, and then I've got an answer box. And then in the middle, I'm going to write my question, or in this case, kind of 2 questions. So in this one, the question is, let's read the whole problem, and then we kind of start by looking at the question. So Marisa wants to buy a DVD player that costs $150. She already saved $25. And she plans to save $10 each week. Write an expression that represents the total amount of money Marisa has saved after any number of weeks. Will Marisa have saved enough money to buy the DVD player in 11 weeks? So what do we need to find? Well, we need to find out, does she have enough money after 11 weeks? So that's our question. Our strategy they gave to us, we're going to write an expression. And now, in order to find this answer, we're going to have to know some stuff. So we're going to figure out, what do we know? What were we given in the problem? So what do you see in the problem? We know that the DVD player is $150. We know that she already saved $25, so she has $25. And she plans to save $10 each week. She's going to save $10 each week. Okay. Now I know that you could maybe find the answer doing it a few different ways, but we're going to write an expression for this. So we're going to start by writing our words, our verbal model. So what do we know? Well, that she has $25. So we're just kind of going to put together what we wrote right here as our verbal model. We know that the DVD player is $150. That's going to help us answer the question, but it's not going to help us do the math for it. So we know our words are she has $25 and she's going to save $10 each week. Okay, now we have an expression right there. We just have to figure out how to write it in math. Well, she has $25 is easy. She just has it. It exists. And means add. And how do we write saves $10 each week? Because it's not just 10. She's going to do $10 and she's going to do it every single week. She's going to save $10 a bunch of times. So since she's doing it a bunch of times, we're going to multiply. 10 times what? I don't know how many weeks she's going to do this for. At least not right now when we're writing the expression. So first we're going to define our variable, and then later we'll use 11 weeks. So W equals number of weeks. I put that up in what I know. So it's going to be 10 times W. That way we've written an algebraic expression. And finally, we can find the answer. So I have my expression that I need for the problem, and now I'm going to evaluate it to find my answer. So I know that weeks is really 11 from my problem. So I'm going to put 25 plus 10 times 11, and 10 times 11 is 121, plus 25, and that would be 146. Don't make the mistake of saying she has $146. That's not what the question's asking. Does she have enough money after 11 weeks for the DVD player? Well, she has 146. The DVD player is 150. Nope, she doesn't have enough money. So our answer will be both our expression, 25 plus 10W, where W equals weeks, and our answer, she will not have enough money because she only has $146. Because she only has $146. Make sure you add why you know it. That because is important. You can't just answer the question. When you're talking to me, you would want to know why I know this. I'm not just perfect. Okay, so the next thing we're going to do is have you try one, and it's actually one from your homework. So you're going to do your homework as a U-Child today. So go ahead and draw this square and try this problem. Pause the video and then raise your hand when you're done. And then lastly, we have one more problem. An online store is having a special on music. An MP3 player costs $70 and song downloads cost 85 cents each. Write an expression that represents the cost of the MP3 player and S number of downloaded songs. Then find the total cost of 20 songs. Then find the total cost if 20 songs are downloaded. So again, they give us our strategy. We need to write an expression, and they point out that they define our variable for us right away. So that means our expression needs to include our variable. First writing your algebraic expression and then finding the total cost. So two different problems. Well, we can start off with right here in our find box, write an expression and find the cost of someone who bought 20 songs. So we've got what we need to do. And what we know, well, we know what the variable is. S stands for number of songs. Shorten that up a little. And then what else do we know? So looking through the problem, what else do you see that we know? An MP3 player costs $70. And song downloads cost, so songs cost 85 cents. Okay, is there anything else we need? No, I guess not. So we need to write an expression that represents the cost. Here's your expression right here. We need the cost of the MP3 player and the number of downloaded songs. So they lay it out for you a lot of times in a problem. So our verbal model, or our words, are the cost of an MP3 player. And right now we know it's $70, so we can just put is $70 in our words. And we're going to purchase, or I guess download songs at 85 cents here. So we can put that in our words. So download how many songs? S songs for 85 cents. Oops. Okay, we can make our expression. The cost of the MP3 player is $70. That's not changing whatsoever. And we're going to add on to that S songs for 85 cents. Again, I'm going to spend this 85 cents a whole bunch of times, so I know that this part of here is actually a multiplication problem. So it will be 85 cents times S songs. Okay, we've got our expression. I'm going to go put it right over here in the answer. And then we can find what it costs for 20 songs. So that means I can substitute in 20 in place of S. So 70 plus 85 cents times 20. And then we've got to figure it out. If you don't know what 85 cents times 20 is off the top of your head, just do some side work. So it's 85 cents times 20. First row is zeros. And it's the placeholder. 2 times 5 is 10. 2 times 8 is 16, 17. And make sure you don't think that this is $1,700. You all know better than that. 20 songs are not $1,700. So check your place values. I have 2 place values after the decimal, so I need to move it over 2 places. $17. So it's going to be $70 for the MP3 player and $17 for the songs, for a total of $87. Go over here, write your answer. An MP3 player and 20 songs costs $87. You're done. So you can head on to doing your homework. And I would like you to use the 4-square model for one of these problems. So 8 you already did, so now pick one of the word problems. Not all these are word problems, so don't worry. Pick one to use the 4-square on. So when you turn it in, I should see 2 4-squares. One for number 8, because you did that in class, and one for one of the other word problems. And remember, not all of these are word problems, so just maybe pick that one right away.